AI agents are failing at complex tasks, not randomly, but in patterns we can now actually measure. Today, 5 stories that show exactly where AI is breaking, where it's being fixed, and what one major software company just decided to do about all of it. Here's the lineup. Researchers have built a spatial reasoning agent that forces computation before language generation, and it changes how we think about grounding AI answers in reality. A new health agent framework confronts the fact that most medical AI forgets you the moment the session ends. A clinical machine learning system learns to read hospital data, even when every hospital formats it differently. A diagnostic benchmark called Horizon maps precisely why AI agents fall apart on long tasks. And Adobe has shipped a conversational AI editing assistant it's calling a fundamental shift in creative work. Let's get into it. One of the most persistent problems with language models is that they generate answers before they've actually solved anything. Ask an LLM a spatial question: where is this object relative to that one? What's the layout of this factory floor? And it will produce a confident-sounding answer that may have no grounding in actual computation. Spatial Atlas is a direct attack on that problem. The paper introduces compute-grounded reasoning, or CGR. The core idea is simple but significant. Before a language model is allowed to generate a response to any subproblem, that subproblem must first be resolved by deterministic computation. The LLM doesn't speculate. It synthesizes results that have already been calculated. Spatial Atlas implements this as a single agent-to-agent server and tests it against 2 hard benchmarks, including Fieldwork Arena, which covers real-world spatial question answering across factory, warehouse, and retail environments. Why does this matter? Because it's a design philosophy, not just a model tweak. CGR is a blueprint for building agents that are structurally less likely to hallucinate on quantitative or spatial tasks. As AI gets deployed in physical environments, warehouses, hospitals, construction sites, the cost of a confident wrong answer goes up dramatically. Spatial Atlas is an argument that the fix isn't more training data, it's better architecture. Most AI health tools have a memory problem. You describe your symptoms, get a response, and the next time you open the app, it has no idea who you are or what you discussed. For a one-off question, that's fine. For chronic condition management, behavior change, or ongoing patient support, it's a fundamental failure of the entire premise. This new longitudinal health agent framework is built specifically around that gap. The researchers argue that truly useful health AI needs 3 things current systems largely lack: follow-up capability, coherent reasoning across time, and sustained alignment with an individual's evolving goals. Not a single session. A relationship. The framework proposes design principles for agents that can track a user's health trajectory, revisit previous interactions meaningfully, and adapt their recommendations as circumstances change, while maintaining accountability for what they've advised. This is a harder problem than it sounds. Longitudinal continuity requires not just memory, but judgment about which past information is still relevant. It also raises real questions about liability and consent when an AI is actively tracking your health decisions over months. The clinical case for this is strong. The gap between a one-shot health chatbot and a system that behaves more like a continuous care partner is enormous. This paper is an early but serious attempt to define what bridging that gap actually requires architecturally and ethically. Here's a problem that doesn't get enough attention. Every hospital organizes its electronic health records differently. Different field names, different units, different structures. A machine learning model trained on data from one hospital system often falls apart when you try to apply it somewhere else. This is called poor schema generalization, and it's one of the main reasons clinical AI has been so hard to scale. This paper proposes schema-adaptive tabular representation learning, a method that uses large language models to create semantic understanding of structured clinical variables, regardless of how they're labeled or organized. The key insight is that LLMs already have broad knowledge about what medical terms mean. This system leverages that knowledge to bridge the gap between different EHR schemas, letting a single model reason across hospitals without needing to be retrained from scratch for each one. The multimodal angle matters too. Clinical reasoning doesn't happen in tables alone. It involves notes, images, lab results. This framework is designed to integrate tabular data with those other modalities in a coherent way. If this works at scale, the implications are significant. Right now, deploying a clinical AI model is expensive partly because of the data harmonization work required upfront. A schema-adaptive system could dramatically lower that barrier, making it feasible to build AI tools that generalize across health systems rather than being locked to one. Everyone working in AI knows that agents struggle with long, complex tasks. What's been missing is a rigorous, systematic map of exactly where and why that breakdown happens. Without that map, it's hard to make principled progress. You're just guessing at fixes. Horizon is a new cross-domain diagnostic benchmark designed to fill that gap. It tests LLM agents on long-horizon tasks, sequences of interdependent actions that require sustained planning and execution across many steps. The benchmark is built to reveal failure modes, not just measure overall performance. That distinction is important. The finding that motivates the work is already well established in practice. Agents that perform well on short and mid-horizon tasks often fall apart when the task horizon extends. But the failure modes aren't uniform. Horizon is designed to characterize them, to tell you whether an agent is failing because of planning errors early in a sequence, error propagation across steps, context degradation, or something else entirely. This kind of diagnostic infrastructure is genuinely valuable for the field. Right now, comparing two agentic systems on long-horizon performance is difficult because failures aren't categorized in any standard way. Horizon is an attempt to create that shared vocabulary. For anyone building or evaluating AI agents for real-world deployment, customer service, research automation, software engineering, this benchmark is worth watching closely. Adobe calling something a fundamental shift is the kind of corporate language you'd normally discount, but in this case, the product announcement actually backs up the claim. The new Firefly AI assistant lets users describe what they want to change in plain language. Type a prompt, get the edit. Instead of navigating Photoshop layers or Premiere timelines, you describe your intent and the system executes it. Adobe is positioning this as a new primary interface for Creative Cloud, not a supplementary tool bolted on the side. This matters for a few reasons. First, it lowers the skill floor for creative software dramatically. Tasks that previously required knowing which menu, which tool, which keyboard shortcut, now potentially require only knowing what you want. Second, it shifts the competitive landscape. If Adobe's suite becomes conversational, the moat around its professional tools changes character. The barrier was always learning curve. That barrier just got shorter. Third, this is a major incumbent making a structural bet that the text interface replaces the traditional GUI for a significant portion of creative work. Adobe has hundreds of millions of users. When they shift the default interaction model, that's not a product feature. It's a signal about where professional software is going. Watch how power users respond. If they adopt it, the rest of the industry follows fast. Step back and look at these 5 stories together, and a clear pattern emerges. One that's more coherent than it might seem at first. 3 of today's research papers are essentially solving the same class of problem from different angles. AI systems that generate confidently without actually knowing. Spatial Atlas fixes it by requiring computation before generation. The Longitudinal Health Framework fixes it by requiring memory and continuity before advice. The Schema-Adaptive Clinical System fixes it by requiring semantic understanding before data interpretation. All 3 are saying the same thing. Raw language generation isn't enough. You need grounding. Horizon adds the diagnostic layer. It's the paper that asks, when these systems still fail despite better architecture, where exactly does that happen? That's the kind of infrastructure the field needs to mature. Not just better models, but better tools for understanding model failure. And then Adobe lands as the real-world punctuation mark on all of it. Because the reason conversational AI editing is viable now, the reason Adobe can make this bet, is precisely because language models have gotten good enough at grounded, contextual understanding to be trusted with professional creative work. The through line this week is trust. Every story is about building AI systems that earn it. Through computation, continuity, generalization, and diagnostic honesty. That's a healthier research agenda than chasing benchmark scores. And it's encouraging to see it playing out across domains simultaneously. Here's the question I want to leave you with. Of the 5 stories today, which one do you think has the highest real-world impact in the next 2 years? The spatial reasoning architecture, the health continuity framework, or Adobe's conversational editing shift? Drop your answer in the comments. I'm genuinely curious where this audience lands. If this kind of coverage is useful to you, subscribe. We do this every day. No hype, no filler. Hit the bell if you want it in your feed as soon as it drops. See you tomorrow.